Hello, welcome back to the last part of Pyjamas Con 2022. So, as you can see, my hair got more and more messy throughout the time. And our next talk actually is this one here. It's going to be about stream lead, and so if you are like me, who are data scientists, who doesn't like doing something very complicated to make apps, then maybe this talk is for you. So, yeah, before we start the talk, actually, there are a few announcements. So, remember to enter the raffle. So, it's actually closing in 2 hours. So, it's like 1 hour before the closing, we'll actually close the form. So, if you haven't done it, now is your last chance. Please do it, or yeah, you won't get the chance to win the book by Jason McDonald. So yeah, so that's a kind reminder of that. And so without further ado, I'll introduce our next speaker here. So Siddharth, hello.
Hey,
Hello. So yeah, well, you're gonna teach us how to use Driblet, which is amazing. So yeah,
fingers
I won't
crossed.
be, talking too much because I will let you talk. I will let you tell us. So I'm gonna put your presentation on the screen, and then you can start.
Sure,
Yeah.
sure. Glad to have everyone here and be here. So yeah, so Streamlit is something that I've worked a bit on in the past 2 years. So I would love to talk about it. And pajama is a great occasion for it. And I am in my pajamas, so I'm in the spirit of pajamas already. So as you can see, the title is Streamlit to build and deploy apps like a data scientist. So let's just get on with it. Let's just get started. So first of all, who am I? I am Siddharth Gupta and at the rate Sid Gupta 234 on internet. So if you just Google it, you will get thousands of spam accounts that I might have created using this username. And I am currently pursuing a cognitive science master's at IIT Delhi. And I also have a YouTube channel on college information in India about higher education. And my hobbies include music, chess, football, and guess what? Sleeping. And I have recently interned as well in Potsdam University. So it's been going uh, cool till now. And so let's come back to the business part of it. So first of all, what is Streamlit? We'll discuss that, and then we'll just take a deep dive into the different aspects of Streamlit, and we'll have a hands-on discussion of how to come up with these different features, starting from installation and the features that come after it, one after another. Then we'll have a we'll build a Streamlit app, and I have it already in readiness, but we will sort of go through the elements that have made it possible after learning all these initial parts. And then I will show you some other examples of my Streamlit projects, and at the end of the day we'll see if we can also learn about how to deploy these apps. Maybe time won't allow, but we'll try our best. That's what we can do, right? So Streamlit, what is Streamlit? So Streamlit is an open source Python library, and it makes it very easy to make beautiful apps and deploy it on the internet. So the problem with other frameworks is that it might come a bit difficult for someone who is more into data science and not into web development. So that's when other Streamlets really comes into picture. So you are a very good data analyst, data scientist, but you don't know web development. So what will you do? Give up? No, you'll learn Streamlit. So because it is very friendly and it is Python first. So if you are into data science, then you already have some idea of what Streamlit is going to be about because it is based on Python. And then you can also deploy it and share in just no time whatsoever. And this is an example that will build at the end of it. And as you can see that it is also hosted on Heroku, that shows that we can actually deploy it quite easily. And then the code is also available for you to go through. So let's try to understand the different features of it. First of all, installation and setting up. So again, you can just clone that repository of xkcd fetcher and just get started with it. And then the usual the usual run of the mill things that you do, which is to create a conda environment, activate the environment, install pip, and then install pip requirements file, which just contain 2 through 3 libraries, including Streamlit, pandas, and numpy. So here you can see the bare bones of Streamlit, how it starts. So you just import the libraries that are relevant to your code, including Streamlit. And then what you do is something called set page configuration. So you give some basic idea of what your pages meta information is going to be about. So what will be the page title of it, how should the icon look like, what should be the layout like, and what should be the status of the initial sidebar. So here layout could be wide and it could be center. So there are two primary layout. So in wide you have the options of breaking down the page into different columns, but in case of center you are only allowed one column. So here I'll go through the code as well in a while. So you create this file, you name it app.py, and you have created the smallest possible Streamlit program. And here you can see what I did here. Uh, is this is the bare bone. This is what happens when you run this particular piece of code. So here you can see this is the structure that we have. I've cheated a bit. I've added numpy library also, but that hardly makes a difference. So here you can see that uh, here you can see that this is the basic bare bone of a Streamlit program, a Streamlit application. This is the bare bone. So what you need to do is you need a command to run it. So after creating this smallest piece of code in app.py, you just need to run the command streamlit run and the name of the script, which is app.py in our case. So what it does, it sets up a server, sets up a local host, and then you can just simply go to your local host link, and you can see that we have successfully launched a Streamlit application, which is nothing at this point of time. Now here, what you can do is we will go in the next slide. So we'll just build one on one the concepts. So here you can see in this slide, what is happening is now we are going to the columns part of it. So now, so as you can see that here, what we did is we gave our layout as wide, and wide gives us multiple columns. So now what you can do is you can divide this whole page into different columns, column 1, column 2, column 3, and so on. And then you can decide on which what would be the ratio of these columns length. So C1, C2, C3, 1, 2, 1. So that means that the page will be divided into 1:2:1 ratio. And then the column would be of that ratio length. And then you can see that if we sort of run this small structure, then you can see that hello Pyjamas world is here to stay. And Pyjama, you can see that it is taking uh, two out of 4 parts of the page, and hello and world are taking one each. So here you can see here in our code, if we let's just quickly go to our code here. What we need to do is we just need to sort of uh, uncomment it, save it, and here let's see what is happening. So what is happening is we have come up with this idea that okay, we can divide the page into number of columns, but then we need to denote the column as well. So we saved it as C1, C2, and C3, and here with C1. So now what I'm saying to Streamlit is that okay, use C1, and on C1, which is the first column, apply this thing. So st.write, so you need to write hello on this C1 column. On C2 column, now we have come to the second column. What you have to do is print pajamas, and on C3 column you have to write world. So here for writing, there is a function called st.write, which just simply puts so if you just refresh it, you can see that it just simply writes it on the page. And now here you might think that okay, pajamas is looking a bit off, so what you can do, is Streamlit is so great that it allows markdown as well. So you can just simply use the markdown, and you can just simply just align it as center, and it will look slightly in the center. So here, if you refresh it, you can see that it is in center of the page. It is not looking as center as it should be, because the world is again on the left aligned, and this is also left aligned. But trust me, this is at the center of the page. So this is how the columns will come into picture. So how easy it becomes, that now you just have to do is set up these columns, and then you have to just with C1 you have to just continuously write on that particular column, and then everything will come one below the other on that particular column. So now let's just uncomment it, and let's explore the next part. So next part we have is, so in the next part we have is containers. So what are containers? In HTML we have divs, here we have containers. So now on column level also we can make subgroups of elements, and that is what a container is. So container is a subgroup of elements, where you will realize where it will come handy, but at this moment I think it sort of helps you modularize your code, and it helps you to understand it better and crisper. So here in the container side, let's see what we can do. So in the container side, here if I do again uncomment it, and you just need to refresh it after setting a server. You just need to refresh it, and now you can see xkd comic fetcher get one random comic is coming here. Why it is happening? Because c1 c2 1 is to 2, so we are dividing the page into two halves of 1 is to 2 ratio, and then c1 and c2 respectively. So now what we are doing is we are saying that use this container and use this container on c1 column, and then do this. So on c1 column you can see some activity happening, taking place. And next part is actually very interesting. It shows us uh, how powerful it can be to have different types of text displays on our disposal. So here you can see, if I talk about the text display options, so here if I uncomment it, you can see what a range of variety we have available to our disposal. And we have markdown, definitely, as we discussed earlier. There is title, there is header, there is subheader, there is caption, code. So you can also have that code like printing on your screen as well. And then text, to the general text, and then latex as well. Latex. So isn't this cool that you are able to render latex as well through Streamlit? So here you can see that markdown. This is how markdown looks because I made it italic. This is how title text looks. This is how header looks, and you can see that the height of it and width of it goes down depending on the title, header, and subheader type of text. And here the caption is, and you see the code part looks so beautiful. I just print, we are having fun in pajamas. We are having fun in pajamas, and different ways we are sort of echoing that sentiment. And here in the latex part, you can see that how beautifully it sort of changes bare latex to a good output, a good mathematical output. So this is again a very powerful thing, that you are able to display such a range of variety of text uh, on your server, on your Streamlit server. And then again, there's a lot of input widgets that are also available. So you have buttons, you have text input, you have radio buttons, and so on. So the list is on and on. But to understand a bit, so here I have just put a couple of examples. So I'll again just uncomment it, so just so we can focus on one thing at a time and learn that particular aspect of the library. So here, if I put on input widget, here you can see, uh, here if I refresh it now, you can see that there are two examples given here. One is the button and one is the text input. So if I press this, you can see that the text changes to button pressed. And if I enter a name here, I'm all pajamas today, so I'll write my name as pajamas. So you can see that the input that was taken from the text box has been used in the printing here as in a way. So here you can see what is happening here. Now let's see. So if this event gets triggered, if st.button, the button, which here the text is written, which text would be written on button, here it is written press. So if that gets clicked, so this bool will become true. Whenever this bool becomes true, you have to write button pressed. So that's why if I refresh it once again, you can see if I press it, it changes to button pressed earlier. And if that doesn't happen, then button never pressed. So that's why initial stage we have button never pressed. But then when we give this input, that changes the bool, and then now it presents as button pressed. And now here you can see the input text is so relevant, because now you want someone to enter something, and then you want to use that data to come up with some calculations that you might need. So here you can so here when I ask someone their name, they enter their name, and then it gets saved as text underscore input. And then we sort of write it again, as you can see that your name is, and then the text input gets printed. So here you can again see that if I write pajamas, it will get printed. So this is a very small demonstration of the kind of tools that are available in Streamlit. So this is input widget, and it will come a bit handy when we talk about a little project that we made. So if I just comment it as well. So again, one more beautiful cheese about sorry, yeah. So again, one more very relevant thing with Streamlit is that it can print chart elements pretty well. So if so it has its own chart library, And besides its own chart library, there is also matplotlib and plotly support. So you can use matplotlib and plotly right off the bat, and Streamlit will render it as well. So here you can see one small example of Streamlit's bar chart. So here you can see that we are sort of creating a data frame, and passing and sort of saving a data frame that's just as is, with the two columns, and then we try to plot it as a bar chart. And here you can see, if I sort of refresh it, here you can see that bar chart has been produced depending on the data frame values that were there. So this is again a very powerful thing. And lastly, there's also media, so you can just use images, videos and audios, and you can show them as well on your Streamlit app. So here you can see, I'll just uncomment it, and I've given an image link. So here if I refresh it, the image comes, and as I said, I'm all pajamas today, so the image comes off the pajamas logo. So here you can just use st.video, st.audio, and this one, yeah. So here you can use st dot audio, st dot video, st dot image, and so on. So sky is the limit. Sky is the limit, and here you can just use any link here to show the image, and so on. So this is the media part of it. Now let's try to see what we can do with our initial problem, which was the xkcd comic fetcher. Come on, what is that? So now we'll try to build this. I've already built this, but I'll go through the steps once in front of you really quickly. So this is our data set. Data set contains of 2496 xkcd images, as well as its metadata associated with it. So you can see that details of 2496 comics are there in the data set, and every comic is sort of having this metadata associated with it. So for this particular comic, you will have month string num2496, link, some alt text, the URL, and so on. So now this is there, and now let's try to see how we can come up with a code for it. So now whatever we have learned, we'll try to sort of set a tone for it to use it. So first of all, we will uncomment this part. So here, let's see what is happening. So first of all, Streamlit is importing, yay, that thing we know from our earlier part of the lecture and tutorial or talk. I don't know what is the right word, but so here you can see that panda has been imported, and here I created a small function which is preprocess. So let's see what this preprocess is doing, just for the sake of completeness. So here the preprocess is just reading the JSON file, and I'm just focusing on the transcript of the text. So in this case, the transcript is empty, but in other cases there is a transcript. So I'm relying on just the transcript. So it sort of preprocesses the transcript part of it, and then returns the data frame. Okay, and then there is a model file which is to get images. So given text, we have to come up with the images. So here the images part is simple. We give a data set, we give a user input, then the user input gets compared with the metadata, which is the transcript part of it, and depending on the value that is there in the transcript part, we get output. So if we look for a query like Python, and if there is a comic which has Python in its metadata, then it will come out. So those are the two functions that we are importing. So right off the bat, C1, C2, now we know what it means. We have created two containers. So now let's see what is going to happen in this function very quickly. So here we have set a title, we have set a header, we have set a file name, which is the data set file. We have pre-processed the data, we have taken an input from the user, and we have taken a num results, which is empty at this point. So let's just refresh it once. So here you can see that I can write anything, and okay, this is working. This thing is working. And now in the second column, we want to print the images. So here, if I refresh it again, if I write Python, something should come here, but it is not coming. And why is the case? Because there is more C2 involved here. So first of all, uh, in first column, I want to write if there is a result for it or not. If there is not a result for it, then I don't want to write it. Then I want to write it that there is no result. If there is a result, then I want to show the result. And now in the second column, I will show the result. Now if I write Python, something should come. So you can see one. So I'm showing 1 out of 10 comics because I cannot show 10 of them. So I sort of here randomly select 1 out of these 10 images. So this is what a small program looks like. And you can play with this. I think this is a very good starting point to get started with Streamlit. This is a very simple program where, given a keyword, you look for you look in the metadata to find where this Python occurs in the keyword, as a keyword in the description, and of alternate text or anything you want to like, and then we can show 1 out of 10 images out of it. So this is how easy it is to create so this is barely 20 to 30 lines of code, and you have a very interesting program here, very interesting program. And and I want to give you the breadth of it, that what is the possibility of it. So you can see some of the examples of small projects that I made. So one of them is a music playlist generator. So here you can see this is also made with Streamlit, deployed on Heroku, and here you can see C1, C2, C3 right off the bat, and then you just have to select an artist. Here, depending on artist, you will have a range of songs that they might have sung. Then you can select the song, and you can get the lyrics as well as the Billboard rank of the song over the years, and then the audio property of the song as well, thanks to a Spotify data set. And then I also had a recommender system in the background that can generate a playlist of songs which are similar to this song. So now you can just click this and you will have a playlist that is similar to this song. So I mean, this is of course in line with the expectations of Streamlit, that you can also generate you can also run machine learning models in the background as well. So this is a little bit about the breadth of this particular library that I wanted to show you. And there was this another project which I made, which was the essay rater, which I made very recently. And here the idea is to rate essays. I just used a pickle file to extract the model. And here, if I write some very cool word, maybe I am extremely, okay, let me correct it. I am extremely happy, then it will give me a vocabulary score of 1.5. If I give it some lesser word, then it will give me a lesser vocabulary. So this is again something that I built with Streamlight. Takes me just few minutes, half an hour maximum to set it up and deploy it. And I don't think we have time for discussing deployment. I thought that I would focus more on tutorial, because then it will really help you get started. For deployment, you don't need a lot of things actually. You just need to create 3 files. One is the setup file, which tells the Streamlit about what kind of theme it wants to have. So if you see here, you can change the theme of it as well. So in settings, you can change the theme of it from light to dark. So in the setup, in this configuration file, you can set the theme of it, so that it is same for every user. In proc file, you just list a command that you want to execute, and then there is a requirement file which tells us about which libraries are needed. And then you can use Heroku to create this app. I mean, to deploy this app using simple two, three commands. And lastly, I just want to say thank you so much to everyone who's listening this, who will ever listen to this, and to the audience, to Pyjamas, to Streamlit, and the documentation, and of course XKCD Comics. I think you all are the real MVP. Thank you so much for the time. I hope I'm in time.
Thank you. It's a really, really good talk. So I have a question because I've been listening.
Yeah.
What what do you think? People, the advantage, because know a lot of data scientists. They use the Flask API and stuff. Like, so what do you think? This is better than Flask, for example.
I think when it comes to deployment, it is very easy. So if you make a very small scale project, then I think this should be like one of those libraries where you sort of push it once and see if it is working out or not. And then if you want to scale it, then you can go for frameworks which provide further freedom. So here you would have certain functions that you can employ, but if you go on Flask, then you can design your own functions. So I think to start with your journey, or if you have some idea prototype in mind, then I think it's better to start with this. and then sort of extend it further.
Yes. So depending on the use case, I guess.
Yes, I believe so.
Yeah, it's cool. I think like well, we all want to learn new stuff and then have more options, and that's really
Yeah.
cool. Thank you for introducing us to the new Slim Lid is a new thing if you haven't heard about it, and thank you so much. Thank you for the great talk, and I hope you have fun in pajamas.
Yeah, it's
And
fun, and I mean, I'm available across Twitter and LinkedIn. So if you have any ideas with Streamlit or anything with regards to data analytics or data science, so you can ping me.
yeah, great. Okay, thank you so much. And I will let you rest a little bit for now. And so, what's going on here? Now, let's see that we actually have our next talk. Oh, it's interesting. It's going to be end-to-end topic modeling. And but we still have a little bit of time. So, what I'm going to do is to play the very catchy music. I know you have not enough of that, so I'm going to play more of those music, and then we'll be back when it's time. So let's go. Okay, so I know that you have been waiting. I know that you want to know how to do end-to-end topic modeling because nowadays we have too much data and we don't know how to do like what to do with them. So, without further ado, let me introduce our speaker, Kayen. Hello,
Hi,
hello.
Chick.
Hello. Yeah,
Good
now
to
I
see you.
can hear you and see you. Good, good, good. So yeah, like you're a data scientist, and you have been a speaker as well. We have a lot in common, I guess.
Yeah,
That
yeah.
I know you have been speaking at a lot of conference. You have been speaking in the PyCon Hong Kong as well, which is I am yet to go to there physically. So yeah, so glad to have you here. And then if your presentation is ready, I'll put it on stage and then you can take us away.
Yeah, yeah, I think uh,
Okay.
it's all
All good?
just okay, just a minute. Yeah, I think it's good. You're
Okay.
able to see my screen, right?
Yeah. We can all see the screen. And there
Okay.
you go.
Can you also confirm whether you are able to see my code as well?
Your code is good. So everything is good. Okay.
Cool.
Take us away.
Awesome.
Yeah.
Okay. Yeah. Yeah. Hello, folks. This is Kalyan. No, I'm from India. So it's some 11 a.m. in India right now. So happy to be part of Pyjamas conference. So this is the second time I'm speaking at Pyjamas, and so honored to be here. So today I'm going to talk about end-to-end topic modeling. So some cheap marketing about me. Professionally, I'm a self-taught data scientist and analytics manager. Apart from my professional stuff, I've been involved with different communities because I love to be involved with different Python and data science communities, and I try to help them and make them grow. So I have different contributions and different organizations, and the other thing is, like, I always love to give back to community, so I always look for an opportunities to share my knowledge in different conferences, as Cheek mentioned. And I'm also a passionate mentor, so I love helping people in different regions on data science, self-learning, or community side. So what are the possible stuff which I can do from my side? So I'll try my best to help people on my mentoring style. Yeah, that's pretty much about me. And so here is the outline for today's talk. We'll start understanding NLP, some overview about NLP, then topic modeling, how the topic modeling works. Then we'll see the popular algorithm called latent directed allocation. Then we'll see some action on topic modeling, and then I'll conclude accordingly. So feel free to drop all your questions, and I'll try my best to answer each and every question for sure. So without any further delay, let's get started. So what exactly is NLP, or what is natural language processing? Well, this is happening right now with both of us. Now you might be wondering, what, Kalyan, what are you talking? So you are listening to my words or speeches, sentences which I'm talking right now, and you are forming some comprehensions from it. So now, when we say exactly the same thing to computers to do that, that is called natural language processing. So natural language processing is a field of artificial intelligence that focuses on communication between computers and human in a natural language. So the overall objective of a natural language processing is to make computers understand and generate human language. So that's pretty much about natural language processing definition. Okay, now when we are talking about NLP, usually starts with unstructured text or unstructured data. So what do I mean by unstructured text? So let me try to explain you with an interesting example here. So add core exercises to your daily routine. Of course, if you include the core exercises in your daily workout routine, you'll build some nice apps in your body. And of course, I wish most of the men would like to have a nice apps in their body, right? So yeah, coming back to the context of NLP here, this is something that you and I can easily understand. What is this sentence all about? So this is something called unstructured text. When we try to communicate the same thing to computers, so if I say this sentence to computers, which computers cannot understand because it is in an unstructured way, to make computers understand, we need to have a structural representation of the same information. So how the structural information looks like is, So this is how the structural information looks like. So the daily routine here, it is an element, and we have a sub element called workout and core exercises. So which we have written in a structural format so that which computer can easily understand and compress this information. So this is called structural data. Okay, now we have a unstructured information and we also have a structured information. Okay, so now the goal of NLP is to communicate between these two, unstructured and structured. That is why NLP sits in between unstructured and structured. Okay, now, when we are going from unstructured to structural, this is called as a natural language understanding, which is also called as a NLU. When we want to go from a structured to unstructured, which is called as a NLG, which is nothing but natural language generation. I'm not talking in detail about NLU or NLG because these are completely altogether different topics, which goes again beyond the scope of this talk. Okay, this is a quick overview about NLP. In the next slide, we'll try to understand some of the use cases which are used in NLP. First one is like text summarization. Text summarization is one of the important use case in natural language processing. The best example is like you have a large quantities of a text data in various forms like magazines or articles. So you want to pull out some nutshell report of those texts. So this is where natural language processing comes into the picture to solve this problem by removing the unimportant text like unimportant text, and also try to convert the text into short semantic text form so that you are getting the overall the nutshell report of the particular text. And next is like machine translation. When you are trying to translate from one language to other language, so we need to understand the context of the sentences. For example, if you are translating from English to French or French to English, whether you are getting a same context of the sentence or not, that is really important, because every word has a different set of meanings and different types, right? And most of the times when we're doing this translation, we often fail, and we'll get different context of meanings. So this is where NLP solves such problems. And the next one is like autocorrect or autocomplete. Autocorrect is nothing but the best example is like WhatsApp. We all use WhatsApp for the communication. When we are trying to chat in WhatsApp, we often type some wrong words or a wrong sentences, and you will see the correct words popping up on our chat screen or the correct sentence popping up on the chat screen. So the reason is like there is an NLP algorithm running behind the scenes, which is making correct ourselves to pick the correct words or the correct sentences. And same thing with autocomplete as well. Autocomplete. So we oftenly encounter autocomplete in our emails like Gmail or Outlook when we are trying to write some emails. Example, if I say that I'll see you, so it automatically completes the next word like tomorrow or maybe day after tomorrow, maybe next week. So it auto completes the next word. So the reason is like there is a NLP behind all these scenes to make it more productive. Next are like virtual assistants or chatbots. The best example is like Alexa, Siri, because they are taking human sentences and they are trying to execute those commands what being said. Same thing with chatbots as well, but the chatbot is similar into a written language. And if you see, the rise of chatbots is pretty crazily in every industry these days. So no, if you take example of starting from from your banking applications to your cab booking or movie applications, every there is a chatbot to address all our concerns. So the rise of chatbots is pretty crazily evolving day by day. And next is sentiment analysis. Sentiment analysis, nothing but when we are trying to purchase a product, we'll definitely look for the reviews for this product right before we actually buy. Of course, most of us will definitely do that, and we see whether the product has a positive reviews or negative reviews. It means that it has some positive sentiment or negative sentiment. Whether those reviews are serious or whether those reviews are serious or sarcastic. Sorry, just a minute. Okay, so whether those reviews are a serious or a sarcastic, meaning that where there are some products which are fake but it has a very serious reviews, and there are some genuine products it has a very negative reviews. So to to solve all such problems, right, NLP plays a very key role in sentiment analysis. And finally, spam filtering. So when we are trying to understand email message, like whether it is the message is real or a spam, so So how NLP can identify is by looking at the context of the message, or it also check whether it has a appropriate grammar or whether the words have been used appropriate or not. So these are some things of which it identifies and conclude that whether the email is a spam or not. That's how it filters. So these are some of the use cases of NLP, and there are also tons of other use cases which have been using in different industries. Right. With this, we have I've given a quick overview about NLP and use cases. So next we'll jump into our main topic. So before we actually deep dive into our original topic called topic modeling. So let's try to get some motivation, because topic modeling is like very quite heavy subject. So I think I thought of let's give some motivation first. Let's get some motivation to understand topic modeling, so that we'll be excited to understand so what exactly and what's going on in topic modeling. Okay, so how can a single person knows what's going on in a million collection of text documents, or tons of articles, or tons of email messages? So how? So it's very challenging for an individual alive to to monitor, collect, interpret, or make sense of it all. So it's quite challenging for an individual to keep monitoring all such things, right? Because there is a tons of information going on all those areas. So how can a single person monitor or focus like what's going on? So over the years, like an area of a natural language processing called topic modeling has made really great studies in solving such problems. So what I'm going to say here, conclude here is, let's not stress our tiny brains here. So let the machines do the work. So with the help of human intelligence. So the reason why I said human intelligence is, so without human intelligence there is no artificial intelligence, right? I'm sure you'll definitely agree with the statements. So let's make our missions work smartly with our human intelligence. Now here comes our topic called topic modeling. So topic modeling, so there are so many definitions of a topic modeling which are there on the internet, out of which indicate very same meaning in a different way. So the straightforward definition here is like it is a statistical model designed to uncover abstract topics within a collection of document. And topic modeling is also called as unsupervised machine learning technique. So why it is called as unsupervised machine learning technique is you need to know the reason behind the unsupervised. So if I say that there is a the amount of a text data is vast and growing day by day, which is indeed true. As the text analytics is evolving, it is increasingly used in the area of artificial intelligence, machine learning, and NLP to explore and experiment the data, text data, in a multiple ways. But the problem here is text analysis or text data is not always straightforward. For example, if let's say you have a large quantities of a labeled text data. Okay, we have a large quantities of a labeled text data. So yeah, we have a labeled data, so you can apply a supervised machine learning technique, and you'll get a good result. For sure you'll get a good results, okay, which is cool. But in most of the real time, right, so what you encounter is that text data is not structured or labeled. So you'll see completely unstructured data or unlabeled data in real time. So this is where unsupervised machine learning approach like topic modeling can be helped. So topic modeling is a form of unsupervised machine learning technique that identifies the hidden relationships in the data. So being an unsupervised machine learning technique, so topic modeling doesn't need any labeled data to work. So it can be directly applied to the set of a docker text data and to extract the information. So that's the beauty about topic modeling. And there is no prior knowledge required about the topics in order to work topic modeling. This is again another beauty. So it randomly pulls out the topic. So there is no, you don't need to have a labels prior or such thing to work topic modeling. And it is also called as a probabilistic modeling because the probability is used to discover the latent semantic structures of the document. So that's why in most of the projects, topic modeling is considered as text mining tool. So there is a graphic which you are seeing on the right side of this presentation. So which basically shows the topic modeling
Hey, Kalyan. So maybe you can share your screen again?
Yeah, I'm doing it.
There is.
Yeah. So you see my
Perfect.
screen, right?
Yeah, you see it.
All right. Yeah. So yeah, I was talking about this graphic which you are seeing here on the right side. So this graphic is basically it's a representation of a latent detection process using a Word document matrix. So this is an example of a topic modeling here. So the columns which you are seeing are correspondence to your documents, and the rows which you are seeing corresponding to your words, and the cells which is here you are seeing it is describing by the number of words which are there in the document. In the dark cells which are seeing here, it indicates that all these are like high frequency words. Now what is that, with the topic modeling we can make a group of documents that are using similar set of words, and that have occurred in similar set of documents. So once you see that all this beautiful word, all this end of the day, you'll see end of the result, you'll see that all this comes with a beautiful topics. I mean, the result will be showcased as a like beautiful topics which you are seeing at the end of this graphic. So you'll see all the dark words are indicating as a one line. So this is the one. So which are nothing but all these are like beautiful topics here. Okay, and some of the use cases of topic modeling here are like annotation. So topic modeling can automatically labeled or annotate the unstructured data based on the majority topics that drives through them. And next one is like SEO in search engine optimization. So the best example for SEO is like Google. In 2018, Google has created an enhancement to the way at created as the enhancement is like to improve their search. So what they have done is like they have added a new enhancement to their knowledge graph called topic layer basically. So the object of this enhancement is to improve their search algorithm. So Google is like also heavily dependent work uses topic modeling in their real time. And the next one is like e-discovery. E-discovery is nothing but in legal documents process, topic modeling can be a savior, and it also makes sure to ensure that no important information is missing in those documents. So topic modeling plays a key role in the e-discovery as well. And there are also many other use cases in topic modeling. So these are some of the important elements which one should know while working on the topic modeling process. So I thought of including these as well, so that so that you'll have a quick idea while you are actually dealing with the problems of topic modeling. So investigate. So investigate is nothing but where we are trying to find, search, or figuring out the large quantities of unstructured data in the text document. So once we're done with investigate, so we look for the basically latent variables. So latent variables are nothing but the hidden thematic structures. So those do not have a label, but we are extracting those topics from our data sets. So once we have done that, so we are making into a clustering. So as we have seen in the previous graphic, so once we have done with the latent variables, we have in finding the documents, and we are creating latent variables. When the algorithm has applied, you will see all the beautiful topic coming into a cluster. So the final output, same thing. So coming to context of the topic modeling, so we are clustering the words with similar expression, and also same with similar documents as well. So this is how our end output results looks like. Now, how topic modeling works. So I thought of including a real time use case study here to explain you the process how it works in a real time here. So I think in organization, or every organization, we offer we I think most of us have encountered a term called customer centric, meaning that organizations have put a strategy where customers are their first priority, because they are core and heart of the business. So without customers, there is no organization, and without no organization put customers as their least priority. I'm sure you will definitely agree with this statement, right? So we listen, we always listen to what our customers are saying. So to put it in another way, we listen what our customers are saying through chats, emails, surveys, or social media posts, or the feedback, and responding in a way, we respond them in a way that encourage them to use our product or service once again, and even recommend to others. So this is how it works in a real time, right? So when even if when some one of the when some of our customer is satisfied, he always spread the word with others to use the service. So this is how it works most of the time in real time. But there is a lot of effort and process involved. How so as a human being, we cannot keep a tab on all such things, right? Because there is a tons of information going on beyond all the scenes. So you cannot keep a thing, you cannot monitor everything as a person. So this is where, so how can we solve such problems? Is the best approach to solve customer-centric problems is through with the help of NLP, and particularly with a topic modeling. So with topic modeling, we can effectively monitor and respond our customers in a timely and effective manner. And on another note, topic modeling can also help and analyze the open-ended responses, like for example, our customer reviews or our product reviews or our feature reviews. So so all these are like very important information, because this can also help to shape our product or service or even encourage our organization growth. So I have personally worked on one of the similar use cases in my work. So I thought of including it to explain this process, to make you understand how it works in a real time. So that's the reason why I just included this particular process in slide by taking different icons to tell you the story about it. Next is like machine learning. So when we always try to explore the ML or AI algorithms, we always end up with a word called black box. So black box refers to machine learning models that gives you a result or reach a decision where you don't know how they have showed up the results. I mean, like how it has showed the results. To explain you in a very simple way, so we'll give some inputs to our algorithm to build a model, and it gives you some output, right? So what's happening inside the algorithm is always a black box, and there is a lot of study and bias going on towards this black box. Again, I'll not talk in detail about the black box because which again goes beyond the scope of this talk. So here, when it comes to context of the topic modeling, we also have a different algorithms in topic modeling, but here in our talk, so we particularly focus on LDA algorithm. So I'll talk LDA in detail about LDA algorithm in the next slides. So here we are taking a LDA algorithm as a black box. We are trying to understand what are the inputs and outputs of a LDA algorithm. So, so inputs here for LDA algorithm are the data sets, which are nothing but a collection of documents, and this is a black box here. So it has three outputs which you are seeing here. So the first output is a cluster of words. So each cluster identifies a topic, and now each words and topics have a certain frequencies here. And if you also observe this cluster, one word can be available in other cluster as well. For example, if I say that there's a word called dog existing in this cluster, so the dog might also exist in this cluster and also in this cluster. So there is a high possibility of that one word can be available in multiple clusters here. Now, if you see the second output under the frequency of words, we can see that we have a different words and we have a different topics, and altogether it has a different distributions. So you can see how it has been distributed here. And finally, you can see we have a set of a document, and each document has a different set of topics here. For example, movie and food. So these has a combination of these words. These two words has a combination of topics which are there in one of those documents. So you can see that each of the document has been segregated with a different color coded here. So this is how our output of our model comes and showcase it. So which you will be seeing practically when we move to the hands-on part. So I guess somehow I guess most of us have some blank faces or maybe confused faces at this point. But don't worry, we'll try to connect all the dots by the end of the session, so that we'll have a fair idea what all we discussed in this overall talk. Just for now, just be patient and follow me with the flow. LDA, as I mentioned, latent direct allocation is one of the famous algorithm, and it is oftenly used in real time and topic modeling. So there is a lot of math involved in this algorithm, but I thought of not explaining not explaining and showcase you all the mathematical formulas, because I don't want to scare you all with all the mathematics here. So I just thought of simplifying the process here. So I'll try to explain it in a very simple way so that you can grab the context easily. So you can understand the LD algorithm with the two principles here. So every document is a mixture of topics. So we can imagine that every document has a several topics that has certain frequencies or certain proportions. For example, if you take a two-topic model, one document has 90% of a data science topics and 10% of a cloud computing topics, while the document two has 30% of a cloud computing topics and 70% sorry. Yeah, 70% of data science topics. And next is like every topic is a mixture of words. So considering the same two-topic modeling examples of a business BBC News, where one topic is all about sports and one topic is all about entertainment. So the common words used in the sports topic can be like country, game, hurdles, or the organizers of the game. So you listen all these words about sports topic, while the entertainment topics can be movies, web series, or actor, actress. So the important thing here is like information can be shared between topics, meaning that, for example, a popular word like budget can be equally applied in both topics, right? Because budget can be applied in sports, but it can also be applied in movies. So this is something very important, where LDA plays a key role. And the best part of LDA is it multitask for estimating both at the same time. So that is the beauty of LDA algorithm here. So meaning that identifying the mixture of word that has been there in every topic, and it also look for the mixture of topic that determines in every document. So this it do all the multitask both at the same time. And it is also very easy to deploy, so there are no hurdles in deploying the ideal algorithm. So it's quite easy the way you do for other ML algorithms. The process of a LD algorithm is again, so what we do is in the first step so I have basically segregated into 4 stages here. So I'll try to explain what the each stage do and how the overall process works here. So in first stage, we initialize the model. So once we initialize the model, we'll randomly assign a topic to each word in each document. So once the random assignment is done, we'll try to calculate the two frequencies here, the topic and word frequencies. The topic frequency is nothing but the count of word distribution of topics in each document, and word frequency is nothing but the count of frequency distribution of words in each topic. So once the stage one process is done, in stage two, we'll update the topic assignment for a single word in a single document. So how this updation will done is based on topic popularity in each document and based on the word popularity in each topic. So based on the popularity, it updates the topic assignment, and there are some conditions here, like it takes some conditional based upon topics in document and words in topic using dialectic distribution here. So this is where your conditional probability comes into the picture in the phase two. So in stage three, what we do is we'll repeat all the two process which you have done in stage one and stage two. So in stage two, we have done for single word and single document. In stage three, we'll do the same process for all the words and all the documents. I mean, like all the data which we have. And finally, we'll, with the iteration of all this process, we'll be seeing that words are inclining towards good topics or beautiful topics. So that's how the output looks like. And finally, we have the important parameters. So all these parameters, I think you should know, so that while you are working with the algorithm, so it makes your job easy. So if you are seeing the yellow box here, which is nothing but the number of corpus or the number of documents, data sets which you have, so it is representing by the M. Let's say you have a 10 documents, so the M will be here, the 10 here. And if you also see the peach box here, which is nothing but the number of words in the document, which is highlighted by N. So under the number of words, so there can be a many words, and one of the words which is representing by a W here. And in LD algorithm, every word is considered as a latent or a hidden topics here. So which is always represented by a Z here. And there are two important parameters which controls the distribution of the document, which is nothing but the alpha and beta. Alpha controls the topic per document distribution, and beta controls the topic for word distribution. And I have just included the same parameters explanation here to get a clear understanding about all these parameters. So with this, we have finished the theoretical aspect or demonstration of topic modeling. Let's see some action now by looking at the code. Uh, okay, so just let me switch to my code notebook now. Okay, all right, so I believe you are able to see my code screen. So I have downloaded a couple of dependencies before running this algorithm. So here we'll start with the data overview. So I have taken the ABC Broadcasting Corporation dataset of Australian news source, the ABC, and it has basically headlines data of news headlines data over a period of 19 years. So this is quite big data actually. Um, so as usual, I've imported necessary suspects here, starting from data manipulation, data analysis to visualization and machine learning library. So all these libraries have
Hey,
been uploaded.
Kalian,
Yeah,
we are a little bit over the time now. And we understand that also you want to show us. So maybe you can wrap up with the example so we can allow the next speaker to start in a couple of minutes.
sure. So yeah, so okay. So next, once I've read the data, I've done some exploratory data analysis. Yeah, so I think most of us are aware. I did some data cleaning and all. So finally, okay, then I've built a model here. So I've what I've done is I've created a term dictionary of the corpus where it takes a unique term based assigning to an index, then converting that list into the headline corpus. So to it generates a term matrix based on the dictionary. So now we are building a LDA model here. So I've initiated the LDA model here where I passed my corpus doc, IT word, num topics. So you can see these parameters here. So once I have built the model, now I'm calculating the coherence score. So you can evaluate the model based on the coherence score. So here I've used the UMass because parameters. And so we considering the computational power, so I've used the UMass instead of other other condition here. So we got a coherence score here now. So this is how my plot looks based on the 15 topics here. So what I have done is now I can quickly visualize and showcase the results of the LDA model. But what I have done is I'll try to also I have also built other models like NMF. I did the same process which I have done in the LDA model. But the overall thing which I would like to conclude here is, so okay, I played with the different. So how can we know whether we have built a good model or not? So this can be accomplished while evaluating the models. So what I have done is I quickly evaluated all the four models based on the one which I have built. So based on that, you can see that LSI has the highest coherence score. So the coherence score, if we have the highest coherence score, that showcase that our model is good and it is performing well. So considering based on the four models which I built, so LSA has the highest coherence score and it has given the good results, and have printed all the topics of a LHI here, and you can see it has a different scores here. And I have also quickly built the final visual scores, and you can see this is how my final visual looks like. And so based on all this final visual, you can see that police and the council words are like most occurring in our algorithm. So you can see police here, you can also see police here, you can also see council. So these are important topics that have been pulled out from our oral algorithm. So so yeah, considering the time challenge, I was not able to explain in detail about the process, but this is how we come up with our results. And now so that's all about the algorithm action process. And so if you want to study something in detail about the topic modeling, you can definitely check out this resources. And with this, I've concluded my talk. And if you have any feedback, or if you have any feedback, suggestions, improvements, or complaints about me talk, so feel free to write me in this platform. So I'll be responding each and every message which I get in these platforms for sure. Yeah, until next. And thanks again for having me in the Pyjamas, and I'm so happy to speak again in the future as well. Thank you.
Okay, thank you so much.
Yeah, thanks, Lisa.
Yeah, no problem. Your talk was super interesting. Thank you so much.
Thanks again. Yeah,
Yeah,
I'll see you all again.
take care.
Yeah.
Okay, so we're running a little late on time. So I'm just going to call Joseph to the stage, and his talk is how I gave 90 instances of feedback to my team last month and why they loved it. Joseph is an R&D team leader and public speaker. We're really excited to have him present for us tonight, so I'll bring him up. All right,
Hi, thank you
Joseph,
very much.
how are
Hi,
you?
I'm fine. For me, it's morning, so good morning, good night, wherever you are.
Yes, yes, it's good night for me. So, all right, I won't take up too
Yeah.
much more of your time. I will get your presentation started and
Okay.
go right ahead.
So, hi everyone. I'm very happy to be here. When I do this talk in person, I ask the audience, how many of you think that you get enough feedback from your manager? So, do you think so? Uh, Usually when I give this talk, so all of the audience, most of the audience say that they are not getting enough feedback from the managers. Feedback is the best way we can improve ourselves. It's the way we can um, be more effective at work. We can stop doing what's not effective, and we can do more of what is effective. So why managers don't give enough feedback to the people they manage? I think that this is because managers don't know what to say. We are never taught how to do it, how to deliver feedback. So we prefer not to do it, we prefer to postpone it to maybe some other time, maybe wait to the next one-on-one, maybe wait to the next annual review, and eventually it becomes irrelevant or the problem becomes much bigger. So the conversation is even harder. Today, I'm going to share with you a simple feedback model that I've been using for the last couple of years now. It has been very helpful for me and for my team, and I was able to deliver a lot of effective feedback to my team. So we're going to talk about the feedback model, why I love it, and the reaction I got from the people I manage. So first, a little bit about myself. My name is Yosef Arbiv. I work for Cisco ET&I, which is the Emerging Technologies and Incubation Group at Cisco. And currently, I am the Open Telemetry Engineering Group Leader. I have 12 years of experience as a team leader and engineer. So the feedback model that I'm going to share with you today is from the Manager Tools company. They are the one who developed this feedback model. The Manager Tools is a consultant company in the US. They are recording a weekly podcast for over 16 years now that have more than 400,000 downloads weekly. They also have 150,000 subscribers that are paying them money for additional content. So if you like what you hear today, I really encourage you to search for more content from the Manager Tools. I really like their guidance. So the feedback model is made of 4 steps. We're going to talk about each one of those 4 steps separately, and then we're going to, I will share some examples on how exactly does it sound, and then we will have some more deep walkthrough into each one of those steps separately. So the first step of the feedback model is to ask the direct, can I give you some feedback? Or do you have a second? We want to make sure that the other side, the person that you are giving the feedback to, is willing to hear us, is willing to get the feedback from us, and that they can hear us right now. The second step is to describe the behavior that the other person did that you want to give the feedback on. It can be a positive behavior if this is a positive feedback, or it can be a negative behavior in case of a negative feedback. So in this part, we will describe the behavior. When when you are late to a meeting, or when you update the Jira status when you are done with it, or when you open a pull request that resolves more than one issue at a time. The third step is to describe the results of this behavior. Here's what happens. For example, if the person is late to a meeting, when you are late to a meeting, here's what happens. It makes us lose time, and we may not be able to finish on time, and disrespectful of other people's time. So this is the third step. We want to describe the consequences of the behavior. And the fourth step is to talk about the future. We always want to finish the feedback when we're talking about the future, so we keep the feedback focused on the future. So in case of a positive feedback, we'll simply say, thank you, keep up the good work, thanks. In the case of a negative feedback, we will ask the direct to work on that, to change the behavior in the future. So it will sound something like, can you work on that? Will you be able to change it in the future? And we want the direct to respond positively. We want to hear them commit to actually changing their behavior in the future. So let's have some examples of how it actually sounds when I give someone feedback using this feedback model. So it's something like, hi, can I give you some feedback? When you update the Jira status, when you're done with it, it helps me keep track of the sprint progress. Thanks for that. Or when you send the meeting agenda in advance, it helps everyone come prepared to the meeting and makes the meeting more effective. Keep it up. Another example would be, hey, do you have a second? When you open a pull request that resolves 3 different issues, it makes it harder to review it. Can you change it in the future? So the first step is to ask if I can give a feedback. The second step is to describe the behavior that we are giving the feedback on. The third step is to describe the results of this behavior, how it affects me, how it affects other people. And the fourth step is either to say thank you in case of a positive feedback, or to ask them to change their behavior in the future in a case of a negative feedback. So let's talk about each one of those steps separately. The first step is to ask the direct if we can give them feedback. The reason that this is so important is first because we want to make sure that the other side is actually willing to listen and they're in a state of mind that they can hear us. There is no sense of talking to someone if their mind is somewhere else. So we want to make sure that we're not disturbing them, that they're actually willing to let us give them some feedback. Of course, if our direct tell us that they can't, that they don't want to hear us for some reason, maybe they are busy, maybe they are in the middle of something, so we will drop it and we will try to give them some the feedback in some other time. The reason that this is so important is because it changes the state of mind in the direct. So they know that they are now getting feedback. So it's not just some random conversation, but they know that we are delivering them feedback right now. So they are in a state of mind of receiving feedback from us, from their manager. The second step is to describe the behavior that the direct did. In this step, it is very important to describe something objective that the direct did. It must be something that they actually did, that they have control of, not something that we think they think, not something that they thought or other thing. It must be something that we can see that they did. So imagine that the room is videoed with a surveillance camera. So it must be something that we can see on the video later, or we can hear on the video if it's recorded. So we don't want to say something like, when you come to the office with this attitude, or when you're upset during a phone call. We want to say something like, when you are smiling during a phone call with a customer, or when you are yelling at someone in the office. It must be something that we can see them do or we can hear them do. It must be something objective, so they know exactly what we are giving the feedback on, and they know what should they change in order to behave better in the future. The third step is to describe how their behavior is affecting us or other people or the company or our business. So we want to describe how what they did is either good, has a positive effect on us or on other people around them, or it has negative results on the company or at anyone else. In this case, in this step, it is okay to describe something that is not objective, something that we think or how we feel, because here we describe their behavior results. So it is okay to say something that it is not completely objective. And the fourth step is to talk about the future. It is very important to finish the feedback with when we talk about the future, because we want to make sure that they know that we are not picking up on them on something that they did in the past for no reason. We want them to be better in the future. We want them to have a better performance in the future. We can't control the past. We can't do anything with what already happened. So the only reason that we're doing this conversation, the only reason we are giving them feedback is because we want them to be better in the future. So we always finish the feedback with something that is related to the future. So in case of the positive feedback, we'll say, thanks, keep up the good work, keep it up, something like that. And in the case of a negative feedback, we'll ask them to behave differently in the future. So in the case of a negative feedback, we will ask them to change it in the future. Can you work on that? Can you change it for me in the future? This is the only part of the feedback model where we have two different steps, right? For the positive feedback and for the negative feedback. And in the negative feedback, it's really important to ask, to wait for them to respond, to get the person that we are giving the feedback to answer yes to this question. We want them to commit to actually changing their behavior in the future. The reason that we want to make sure that they are committing to changing the behavior is because when they are saying, yes, I will work on that, it increases the chances that they are actually going to change their behavior in the future. So we want them to answer yes to this question. We want them to commit to actually changing their behavior in the future. So I'm sure that you're all thinking, isn't it a little bit awkward? It sounds like a not so natural conversation. It's maybe sound like a script that someone wrote for you. And it's really weird to have this kind of conversation with the people I manage, the people I work to day. But it was also like that for me. When I just started to give him feedback, it felt a little awkward. But the importance of feedback is so high. The feedback is a great gift that we can give to the people we manage. It helps them be better each and every single day at work. Imagine that your manager knows something on your behavior that can make you a better professional. Wouldn't you like your manager to tell it to you? It is okay to have a little bit of awkward conversations, but to help the people you manage be better, to help your team be more productive, and to be a better manager for your people and for the company that you're working in. And another thing is that as you will give more and more feedback, it will become more natural to you. You will have it more easily. It will become not awkward at all. And the people you manage will also get used to it and will be really happy to get it from you. So I really encourage you to start using this feedback model and to start practicing it. And as you will give more and more feedback, you'll be better at it and it will feel more natural to you. So why I love it? and why I've been giving so much feedback for the last couple of years. The first reason is that it takes no time at all. It takes 10 seconds to deliver feedback. You can do it whenever the other person has some free time, when you catch them at the hallway. Of course, not in front of other people, but you don't have to wait to some meeting or to schedule something in your calendar. The second reason is that this is behavior based. The second step of the feedback model that forces us to describe an exact behavior that someone did makes it focused on a behavior, on something that the other side can control, something that's in their hands. And it makes the conversation less emotional because they know that we're not talking on them, we're talking on something that they did. And the feedback model is always focused on the future. We are not punishing them. We are not just picking up on them. We are talking on how they can be better in the future. So we are always talking on the future. We're never talking on the past. Let's talk on some of the responses that I got from the people I give the feedback to. So you can see the cat's face. This is the usual expression that I get. Hi.
Okay, hi. Yeah, it seems like we've run into some technical difficulties. I'm going to see if I can get your presentation back up on the screen.
Yeah, I just shared it again.
Okay.
So where were we? Just 1 second. Okay, we were here. Okay, so this is the face I usually get when I start delivering the feedback, when I start rolling it out. And the great thing about it is that after a couple of weeks, when people say that they're getting a lot of positive feedback, and even the negative feedback is not about them, it's about something they control, something that they can change, this expression disappears. People say thanks. People like to get feedback. People enjoy the feedback. So this is the first response that I get. Another response I get, usually when I deliver positive feedback, I get this a lot. I was wondering if this is actually good or not. And this is something that can really explain why feedback is so important. Because they did something and they were thinking if this is actually good or not. They didn't know if they should be doing more of that or they should stop doing that. And by me telling them that this is actually a good behavior, that this is something that I want to see more, it helps them know that this is something that they should repeat in the future. And it helps them be more productive in the future. This is something that I get usually when I deliver negative feedback. So people explain why they had to do it. They say, I had to do this because ABC. And this is okay. It's very natural to try to explain why you did something wrong. And I totally understand that. But I'm not interested in discussing why you had to do it. I understand that you had good reason to do it. I'm just asking you not to do it in the future. So can you please work on that for me? This is how the conversation sounds, and this is completely normal. And this is my favorite response. When someone says to me that for a positive feedback, that this is the result of a previous feedback that you gave me. So I knew I had to do it, so I did it again. And this is actually why this feedback is so good. I can actually see the results of giving feedback, how it improves my team effectiveness. So last thing before we wrap up is that I wanted to keep it positive. Usually when people think about feedback, they think about negative feedback. When I give feedback, I try to give 90%, at least 90% of positive feedback. I do it because first, there is much more positive behavior than negative behavior. most of what people do is good. So there are there's much more positive things we can give feedback on. The second reason is because positive feedback is much more effective than negative feedback. It is much more easier to keep doing something that you are already doing rather to change your behavior and stop doing something that you're already doing. To change your behavior, it's much harder. And the last reason is that when you give a lot of positive feedback, people know that you can see them. You are seeing the good things they are doing. So when you're giving them negative feedback, they will be open to receive it, and the chances that they will implement it are much higher. So again, this is the feedback model of the manager tools. If you like it, I really encourage you to search for more content on the manager tools feedback model. I really encourage you to start using the feedback model. Has been great for me for the last couple of years. I'd be happy to take any question now, and thank you for listening.
Thank you so much, Yosef. That was really, hold on, let me remove this. Okay. Yeah, that was a really amazing talk, really thoughtful. It makes me want to work on a team that you lead with this sort of feedback model, especially when you talk about wanting to have like future-minded conversations with people.
Yeah.
I think that that's really great. I feel like it would make me feel like heard and noticed. So yeah,
Definitely.
thank you so much for that.
Thank you very much.
All right. Well, yes, take care. Have a good night.
Bye.
All right. So I hope you all enjoyed Yosef's talk. Coming up next, we have a really great talk on Paketo build packs. So stay tuned.
Hello. Was a really nice couple of talks. But it's time for the next one. So I would like to invite now Ram to the stage. Hello, Ram. How are you
Hey,
doing?
Christian. I'm doing fine. How about yourself?
I am sleeping already. That's why I'm wearing glasses, because it's too early
Yep,
here
I
on
can
this side of the world. But I am really looking forward to your talk. It's a really tricky topic in Python. I mean, packaging applications and everything is something that every Pythonista knows that can be a little bit tricky. So I can see your slide already. I will not take more of your time. So the floor is yours. Good luck.
Thank you very much. Hello, everyone. I hope you've had a wonderful time so far at Pyjamas. Before I even begin, big thanks to all of the organizers for having me. And I just would like to share some stories about an open source tool chain that the community that I manage and I'm a part of is basically creating and maintaining in order to package and help deploy Python containers. A brief introduction. My name is Ram. I am the chief evangelist at the Cloud Foundry Foundation. For those of you who might not know what this is, so it's a governing body. We are a directed fund under the Linux Foundation, and we basically oversee a lot of the management and governance around the Cloud Foundry project. And in addition to that, we have like a bunch of other projects that are in the Cloud Foundry ecosystem. For example, Paketo, and we have Open Service Broker and a few other CI/CD tools, so on and so forth. My job there is to basically build awareness of some of the tools that we build as a community, and also, basically make folks aware of what the tools are, how best to make use of them, and how best to work with them. Today we're going to dive deeply into a particular tool. They're commonly known as build packs, and anybody who has used Heroku in the past are probably aware of build packs. And they were started in the year 2011, so that's like a little over 10 years ago, which is like 1,000 years in computer kind. But it basically started a decade ago as a means and way to package applications in order to prepare them for deployment. So the goal of a build pack was to detect the language in which the source code that is supplied to it is written in, assign the right kind of build packs, or the tools that will build it, and then create an immutable artifact out of the source that can then be deployed to any infrastructure of choice. Now, along the way, build packs sort of diverged into two. So there was the original Cloud Foundry Heroku version, and then there was a forked, what was known as Pivotal back then, but was essentially a Cloud Foundry version of the build packs. About 4 to 5 years ago, these communities converged once again, in the light of Kubernetes becoming very dominant, in the light of cloud native technologies becoming very dominant. These two communities decided to converge once again and focus all of their efforts on creating what are known as the cloud native build packs. I'll quickly show you the website too. So buildpacks.io is the website for cloud native build packs. So this is a project that is owned by the CNCF, the Cloud Native Computing Foundation, and they basically provide the spec for what the build packs are. And then using this spec, we basically derive the other build packs, and those build packs allow you to package your application and things like that. Cloud native build packs are essentially, like I said, a specification, and one of their chief sort of claims to fame is that they help avoid Docker files, among other things. Now, it's reasonable to assume that when your developers are already doing like 18 things right now in order to build the application, containerize it, and put it on production, writing and maintaining Docker files can be a little bit of a cognitive overhead. It's a technology by itself, and it's kind of not fair, I guess, to expect developers to know an additional technology just in order to containerize it. Now, build packs were created with the idea that builds should be reproducible, they should be optimal, and they should just work. I mean, without having any application developers or application development teams rewrite a lot of the stuff that is required in order to do the build. The builds should just be able to work and work efficiently. So that's the goal with which build packs were created. And today we are going to talk about a specific implementation of the build pack spec known as Paketo. Now, Paketo is an open source project. It is, like I said, it is owned by the Cloud Foundry Foundation. Big chunk of maintainers for this come from Heroku and VMware and like a whole bunch of different places. SAP has also demonstrated considerable interest in the Paketo build packs project, and we're seeing a lot of different teams adopt build packs for their build infrastructures and build pipelines. I'll get into some details about who they are and what is on the inside and stuff like that. But before we do, the fundamental idea that Paketo build packs and build packs in general preserve is build packs should work irrespective of what language or framework is being put to use. So it presents a uniform and homogeneous interface irrespective of what source you provide it. That being said, if your web application is composed of like many different languages or language families or framework, as it should be in this era of microservices. It is also possible to make use of build packs to build apps that are written that way and deploy them. Basically, a deployment is obviously um, something slightly outside the context of the packet build itself, but we'll take a look at all of these different things shortly. And the reason I named this ship more script less is basically because of a lot of the cognitive overhead that it removes, and second, a lot of the actual effort that developers have to do in order to make use of these build packs itself are eliminated. So let's take a look very quickly at what a demo looks like. So what I'm going to do is I'm going to clone a repo. That's basically a Python repo from somewhere. Let's see. Sorry. So there's probably like a hello world in here somewhere there. Yeah, so very simple hello world Python Flask application. So let me quickly clone this. Yep, so that's empty. So we clone that. Okay, so it's organized like this. So I'm going to put the app. Okay, so here's like I think a very basic Python application, and then this. What I'm going to do additionally is to just create what is known as a proc file. And a proc file is basically going to tell the app what the start command is. So let's see, just to make sure. Yeah, so the start command for this is looks like that. So let's copy that into what is known as a proc file, and I'll copy this from one of the samples that I have. Oh, and then let's see. So instead of this command, basically say, I hope that's right. It's got to be this app main.py. Okay. Okay, so hopefully this works. Let's see. So my command for building this is going to be pack. So pack is a CLI that you can find in cloud native build packs. It's built by the cloud native build packs. It's on their website. So this is the CLI that I'm going to be using. So it's a tool that is basically used to manage the entire life cycle of the build packs and the build process itself. So the command that we are going to use is pack build, and then I'm going to give the image a name. So in this case, like nothing too creative. And then one of the, or you can provide it two parameters. You can specify a build pack, but I'm not going to do that. But then what it expects is you need to show or tell this one what the builder is. So in this case, I'm going to make use of a Paketo build packs, and I'll quickly show you what the list is. Pack builders suggest. Yeah. So basically, Pack has a bunch of builders, and builders are basically build images that we are used to seeing in the outside world. So Google, Heroku, and Paketo are like the three available sort of build images, and then we can make use of different build images in order to actually build the app. So that's the one that I'm going to be using, and let's kick off a build. Missing something, obviously. Pack build. Builder. Here. Okay. So then, just like any container build process, this is going to go ahead and download like the whole internet for us before building the container. And so this basically kicks off a process where it composes the web application into several layers, and then it's able to get the OS layers, the libraries, and all of the other dependencies. And what's interesting to me as a consumer, obviously, too, is I don't have to specify what language or what framework the app actually is in. So this is the exact same experience you would get if you were building any other app. Like it could be Node.js, it could be Java, it could be whatever. But although this community doesn't really care about that, so it'll detect your language. It will then read into what kind of dependency management is in use here, and then it will apply that build process appropriately. So I'll just quickly switch to some slides here while we talk about that, and I'll come to this a little more. So basically, that's what I was talking about. Any image is composed of like apps and dependencies all the way down to the OS, and basically once you create these layers and create the container, you're able to deploy them to a container runtime. Now if you have source code and a Docker file, obviously you're building a Docker image, but in this case you're still building an OCI compatible, an open container image compatible image, but you're doing that with the pack CLI. And so one of the pieces that's here is the Paketo builder, like I showed, and then all of the other stuff is made use of with the app itself. And so this is the demonstration that we have going right now. So there is a Python app. There are the Paketo build packs that are going to be in play, and these are all invoked by the pack CLI in order to output an OCI compatible image that has the app, that has the language runtime, that has the library, and all of the other dependencies. It's taking a bit of time, but I think we'll get there. So let's continue to watch this demo, but I'll speak to some of the things that are going on here. So Paketo is capable of creating these app images irrespective of what container libraries that you make use of. Whatever dependency management tools that you make use of. So seeing a lot of progress here, which is good. So you could use any of like the popular dependency management, but it will still function like fully well. And then especially for like Python devs, where I've seen a lot of difficulties mentioned about containerizing Python applications, Paketo works in order to sort of eliminate all of those difficulties that arise from the whole containerization process. So there's no need to have separate builds for like local and staging and production and things like that. So Paketo is fully capable of creating a uniform, homogeneous, repeatable build process that works not just locally, but it will function the exact same way on any remote staging instance that you want to use this on, including production. And so that, again, in my opinion, is like a huge win, not just as somebody who showcases this, but also as somebody who makes use or consumes this technology. And so after all of the downloads have begun, let's just switch to this very quickly. So because there's no previous image with the same name that was found, the build packs will start to list all of the different build packs itself that will participate in this. And so we have C Python that's going to get kicked in. We're going to have pip that's going to get kicked in, and we are at the end of the build. So as we were talking through that, the rather long sort of build process completed. So let's see, I'm going to run this locally on a Docker runtime that I have. Sorry. Yeah, so there's nothing there. And so let's do a Docker run. Let's see if this works. Okay. Let's see. I'm going to delete this. I'm going to pack build this again. Second time this will be much faster, hopefully. Yep. So you can see how fast that process is because of all of the caching that it has. So this is again one of the advantages of using Paketo. But let me try and run this. Yes. So now we have an app going. Yay. So we've containerized this application. It's running. It's fully functional, right? So again, I have not seen this app before, and I didn't make use of the Docker file. You didn't have to like do any additional configuration and things like that in order to build it. And Paketo again is able to detect the language, apply all of the dependencies that are required, and get everything going in order to make the app actually fully functional. So again, we did get a chance to demo how quickly the app is able to manage changes. Let's see now. I'm going to alter a few things here and see how quickly it functions now. Build using Paketo. Show at so I'm going to alter the code and we're going to see how quickly it's going to work again. So pack build, same container name, obviously. I'm just going to run that. And again, it's very fast, largely because obviously the app is small too, but also because it's capable of that kind of caching and other things. Now, yeah, the app has updated. You can see that, and it's basically showing like the new stuff. There are Paketo samples that you can make use of. So I'm going to so you can make use of different package managers and see what the container will look like. It's you're going to be able to make use of any container management dependency management tool of your choice when using Python, and the the build experience will look exactly the same. So Paketo is fully capable of detecting which of the different package managers you're using and load your dependencies that way. So yeah, that's a big part of the demo. We're kind of running out of time. I'll showcase one or two other things very quickly that will really demonstrate how you can make use of. So one of the things you can do is load the image in for deployment into like a local kind cluster. I don't have one running, sorry, I should have set that up. And then one of the other things that we can also do is download SBOMs. So SBOMs are like a big deal right now, largely because open source software supply chain security is very important. Paketo has a default way in which it creates SBOMs. So if I switch to this directory, you will see that it has like very detailed SBOMs that are created, and these SBOMs are they're all organized depending on all of the different build packs that participate. So both CPython and pip install have participated in the build of this container, and so it contains all of the data there. And one of the things that I also like about this is it creates the SBOMs in all the different formats that are required. So Cyclone DX, SPDX, and SIFT are like the major formats for SBOMs today, and Paketo creates that for you by default. So these are some of like the additional benefits of using Paketo. But even without all of these frills, I think it's a great technology for the Python community to have and make use of in order to create containers and make use of those containers wherever. Right. So a lot of benefits that you can derive in order to containerize your apps and ship them without having to get into a lot of the heavy duty scripting and other things that are involved. And so that's why I decided to name the talk Ship More and Script Less with Paketo Build Packs. Thank you for listening in today. Thank you to all of the organizers for making the talk possible. Hopefully, I'm able to return in a future edition of this conference. But thank you very much.
Thank you very much, Ram. Really interesting topic. I have many friends that are really into Docker and everything. And yeah, I do hear time to time that they lost a lot of time complaining about scripting too much. And this sounds like I was not aware of Paketo, so it was really cool. Nice. So we don't have questions at the moment. It will be maybe really convenient if you can share on Discord maybe some links or something to try to get to some demos and stuff like that. And yeah, just thank you again for your participation and wish you a nice Sunday.
Yeah, thanks, Christian. Thanks for having me.
Bye-bye. So we'll be right back in a couple of minutes. Last chance to get your cup of coffee, water, whatever you are drinking at this time in your side of the world. So let's be back in a couple of minutes. And we're back. So we only have two talks remaining in this really long conference. But not for that they are less interesting topic. In fact, I am really interested about the next one because it's something that I believe is really essential for many developers. So I would like to invite to stage now to Gurav. Hey Gurav,
Yeah. Hi.
how's it going?
Yeah, doing good.
Perfect. What time is it there?
It's 12:30 p.m.
Ah, okay. So you're more than awake and ready to show us the cool things of your talk. I think that I have the slides here. I will not
Yes.
take some of your time, so maybe you can introduce yourself. Yeah. With that, the floor is yours.
Thank you. Okay, hello everyone. How's it going? And I hope everyone is going good. Okay, so let's start. Here is about myself. Once again, hello. My name is Gaurav. I am a high school student, and today I'm going to talk about doing some maths in Python. So, in this talk, we are not solving like complex mathematical problems. Instead, we are just enjoying like what we can do with Python in mathematics, like graphs, some images, and some like integration differentiations, things like that. And I am interested in machine learning in Python, by the way, from since in my eighth grade. And yes, I work at Codeday India as the head of operations and finance. If you don't know about Codeday is a US-based nonprofit, which is basically at Codeday we get excited beginners about coding by organizing code days in different cities around the world. Okay, so let's get started. Mhm. Okay, so I have this Jupyter notebook in Colab. So I'm using Google Colab, and I recommend you to use Google Colab to avoid any issues like installing libraries. Like I have an error right installing this, which is base map. So I recommend you to use Colab and end of the HC operations. All right. So let's start. Okay. I hope that font is visible to you and all good to go. So the first thing that we have to do is to installing the required libraries. So we need NumPy, Pandas, SymPy, which is the main man of the day, and base map, which is I'm using some like drawing some maps in Python, like we are plotting something into the map. So we need base maps and IPyWidgets that doing something with matplotlib graphs. So let me run this cell. NumPy Panda seems already interested on already installed in Colab, so just going further. All right, so this is done. So firstly, I will tell you that which libraries we are using. So firstly, which is the main, which is SymPy. We are using SymPy, which is basically SymPy call for the symbolic mathematics, and it's like as written in its website that it aims to become a fully featured computer algebra system while keeping the code as simple as possible. So yes, I personally tried to the SymPy code is very small. Is like you can short the code. I will show you later. So here is a sample code from the SymPy. Like in this, there is a variable which is assigning to the symbol variable in of the SymPy, and we are just plotting an expression which is x. Okay. The second library we are using, which is matplotlib, which is generally, I think all of you know about generating graphs or drawing graphs in matplotlib. Next, we are using IPyWidgets, which is like a sort of addition to the Jupyter notebook when it's come to the creating widgets and like working with graphs more interactively. So here's the sample code. I will show you the demo what IPyWidgets do. Something like the drawer on the Jupyter notebook. And the fourth that we are using is called NumPy. So all of you maybe know NumPy. It is basically for the numerical computing in Python. So it's a Python library which is like mainly has a arrays and working with arrays. Here is a simple array. Alright. So the Python standard library has already a math built-in module. So firstly, we'll explore that. Then we have a couple of more, like you can see in the sidebar, we have these types of things, which is a little bit of advanced topics. So here I'm importing the mathematics library, and here's a function called math.c. So let me run this, and here you can see that the variable which is assigned math to c is 7.9, which comes to 8. It's basically a round of the things, and 9.2 which comes chance. In the math library or the built-in module in Python have something called math.py. So we'll try to find the area and the circumference of the circle. So here's the radius that was given to us, that was 3. So r is equals to 3, which is basically the radius, and the formula of the circumference is 2 pi r. So the formula became c equals to 2 math.py, which is basically the pi in, which is 22.7 into R, and here's I'm printing the stuff. Secondly, there is another thing called area in circle, so which is math.pi into R, which pi r square is the formula of the area. That's why we are using 2 times R. Let me run this. And yeah, you can see that pi has a value of 3.14156, blah, blah, blah. And here's the circumference and the area. So this is very simple, I know. All right. Now it's time to do some factorials. So here's a block of code written in the core Python, like in the fresh Python, from this to this. But this is just one line of code that is math.factorial and the number which for which factorial you want to found. So you can see that how the math function is helpful. Instead writing this, we can just pass this function to get the value. Alright, as I said that we are using the SymPy. Let me run this again. Okay, yeah. As I said that mainly we are using SymPy, so it's good to use learn some basics in just a couple of minutes. I will not recommend it, but like we are using SymPy, so it's better to have something. So firstly, here we are just importing the SymPy as SNP, and this is very important. Like just like in the Flask, we have app, run, debug, something like that. Same in the SymPy, we have symbols x, y, and z, which assigned to a symbols x, y, z. So SymPy is nothing but like it just created it's just used for creating like symbolic functions or symbolic things in the Python. So if I run this cell, mm, which is actually assigning x equals to x square. Oops, we have an error. Snp.goes. Okay, let me see. Immutable object had no attribution. Okay, so what we can do, just remove this first of all. Let's print x. So it will print just like that. Mm, Why is not variable? Oh, I forgot to run this. This. Now we have, and we need a y also. Just adding y, which is 2 into x, and then x plus y. Let's run this. Hopefully it is going to work. Let's see. Yes. So you can see the SymPy is just like these fancy type of words. If you just say the print x, it will print something like that. Like you cannot play with this. But when it's like 3x to the power 4, you can actually do some cool things with the help of SymPy. The next thing, which is called the factors. So here is a simple quadratic equation I have. Now I want to do a factor of this. So for a SymPy, we have a normal function which is called factor. Just give a variable quadratic equation, and it will pass out with you a cool factor. Like you don't have to use pen and paper all around. Just use the Python, I would say. We have another, like in this we are squaring this factor, like we are squaring a and b factor, which is again the nice answer. Alright. The next thing in the same pie that we have is called something solving equation. So x, which is I said that this is very important. Again, I'm using this at the x, which is x symbol x, and solving this equation, which is again a quadratic equation, and it will give me the answer which is nothing but a minus 1. Another thing in the algebraic expressions, like we are plotting something. So for example, here we are just plotting the x sin x. In the SimPy has its own feature which is called plot, which is similar to the matplotlib, but it has different powers. Now here there's some main a little bit of advanced examples comes into the play. We have solving linear inequalities. So again, we are using SimPy, just importing a couple of things and get just importing a couple of things. And here's a main function that we are using to solve this complete linear equality. And here's the thing that here's the input that I given. You can use input in this. Let's try to run this. Cool. So yeah, it's something like linear inequalities in Python that you can use. And this is seriously very interesting to me, and hopefully you will also like it. Yep. So this is something I named it called Life Fun. So it is something like that. Let me show you. It is something like that, which we have created using the math in Python. Like you can draw something like that. And this is the work of the iPad widget that that we have installed earlier. So let me explain this the code block. So this is something like we are importing the libraries we required. We are using random just to like create random plots. By the way, it's created this type of image at when we got couple of like more points. Like if we get 10 points, like 4 to 4 points. Like if we get 0 points, it will create something like that. 0. If we get 6, 7, 7, it will create something like that. But if we create 3, 1, 4, 4, it makes like similar, very similar to the Basel thing. So in this, we have just importing the libraries, and we are creating a function which is shrunk from 1. Here's again some deep mathematical, not very basic calculations. We have another couple of more plots. Then we're getting the probability, like Vitis plot or like random dot random. And then we are transforming this with like where to plot the plot. We are drawing the fun using the matplotlib, or I think yeah, using a matplotlib, and just like here minimum max, which is the slider basically. Like minimum value is going to be 6, maximum value is going to be 10,000. Let me run this again. As you can see that here is a fun with the 10 points, but when I increases that to 10,1089, it will look something like that. When it decreases to 539, which is completely half of that, it looks not very good. This is something cool things that you can do in Python, like mathematics. Another thing that we have is visualizing the earthquake data. Is the complete the CSV file that you can randomly download from the internet. In case I have this, let me see if I can show you. Yep. Okay. Here is the CSV file that I have. Uh, in this code, that we are just importing the CSV, and we are calling to like append, like we have something called empty list, and we are adding something like row number 7. So according to this, the row number 7 is of latitude. We have the latitude is there, and then we have longitude, which is there, and we have the magnitudes, which is there, which is row number n2. Then we have time string, which is row number n10. Then this is the base map that we are using to create this type of map in Python. So it's basically more about the visualizing and importing. Then again, we are using NumPy just to like do sort of things, like solving a couple of things. Uh, Let me run this. Why it is taking time? Okay. As soon as it's done, we'll okay. He's here. Come on, boy. It's almost done. Yeah. Okay, so it's going to be almost done. Yeah, we have successfully done. So here we can see that we can plot the globe with some data like that. So it's saying that earthquakes of the magnitude 1.0 or greater, 25 through 27. The next thing that we have is just called embedding animations in Matplotlib. Still, again, we are using math, some kind of math here, like you can see the cos theta and the sine theta. Again, we are using some trigonometric functions here to create this animation. And to create this animation, we're basically using icon display. Again, it is going to take some moment. Again, let me explain this code. So we are taking the G as a value of 9.8, and here are the intervals, the update position as soon as the animation is growing. Here we are creating the animation. Here we can see that the cool animation that we have created. Okay. Next thing, which is again a bit basic, but I will say it's kind of useful thing if you are into the scientific calculation. It's not very good, like very advanced scientific calculations, but yet it is a kind of scientific calculation. So we are doing a couple of things like in the Python, it is just a functions and the value of if is, which is very simple, but again very useful. For example, if you have to, which conversion would you like to do? For example, I would like to do second one. Oops. Yeah. Enter distance in miles. I would like to say 124. And the distance is kilometers. It is like you can do in the paper and pen and paper, but also you can do in the calculator. And okay, now finally it's time to do some calculus that we all know. I think because as I'm in class 11th, grade 11, so I know a couple of things in calculus. Again, I'm using SymPy to do these calculations because SymPy has inbuilt functions to do calculations or calculus. So firstly, let me zoom out this. We are starting with the limits. So here is a limit that we have. I'm just calling the SymPy function, which is SymPy sine x by 2 plus sine SymPy sine x. It is just the SymPy basically like giving this a fancy type of image, or you can see the text that we have. And here is actually solving like sp dot limit, which is smp dot limit. We need the limit smp dot sign, which is basically limit sign x upon half plus smp dot sign, which is simpy dot sign x, and with respect to the x and the simpy. If I run this, we'll get 1. Yes, the limit is 1. Another example is of cos x. So SymPy has a limit of SymPy.cos x, which is exactly that, minus 1 divided by x with respect to the x dot SymPy.o, which is 0. Let's talk about the derivatives that we have. So SymPy also have something called differentiation or derivatives upon the x. So here simply we are just solving this. So calling the function SymPy, which is SMP, short form, that we imported here. SymPy dot diff, which is the differentiation. 1 plus simpy dot sin x, which is the inside this function, as you can see the brackets, because we have square also, divided by 1 minus cos x, simpy dot cos x, and as this is the square, we'll put square here, and then we have calling with respect to the d upon dx. So adding x here, if I run this, it will solve this equation. So think about a time like how much time it took to solve this equation on a paper and how much time it's taking in this Jupyter notebook. It seems very, very easy. Then we have another thing in SymPy which is called integrations. So here I have an integration of 4 sec 3x and 3x dx. So we are calling the SymPy function SymPy integrate 4 into SymPy sec 3x into SymPy tan 3x with respect to x. So it will solve it again. This is something that actually Python can do, with the help of SymPy. And then we can just use the traditional methods of writing a long code. For example, I'll show you that in the math we have, yeah, by the traditional method, I'm saying that doing by this way or using this way. I think this way is going to be the more better way, and time saving and productive. Instead of writing this long amount of code, we have SymPy to just to do these simple calculations, or maybe more complex, depends on you. Okay, we are at the integration. So if I run this, it's called 4, 3 cos x, it will solve just in a 0 second, you can see. Okay, and next we have another integration, which is 2 upon under root 1 minus x square minus 1 upon x1 upon 4 to the dx. So SymPy, again, we are calling the function to SymPy to integrate this, just writing the stuff that we have inside the braces. And this is the same stuff that we have with respect to the x, and it will solve this in a minute. Next, we have definite integrals. So here is another integral. Just calling this integrate SymPy dot exponent x SymPy dot under root SymPy dot 2 x plus 9, which is gonna this is simply this that we have in this. By the way, this is the markdown, not the image. Like you can see here, this is the markdown. And also we have sequence and a series of something like that in SymPy. So just assigning the new symbol to the n. Okay, we have we have other equation here. Just calling the SymPy to do this stuff. 6 upon 4 to the power n that we don't know, and n comma 0 SymPy dot oo is let's say giving command to the SymPy to do this. We have another thing which is called complicated expressions. I left that. So it is again the type of integration. I've run the cell. So it is basically another thing is long form of code. Think about that. How much time it took to do this calculation manually or even in the calculator, and how much time it's going to take. Like 0 seconds to do this calculation in the Python. This is something that's very cool about SymPy. Most people still, and we can use this in the high level computing. All right. We have another expression that we are going to integrate. This is a bit long, so I'll just run it. It is going to take time. Okay, we solve this. It just took 7 seconds to solve this equation. That's the power of SymPy. Next, we have improper integrals. Again, we have 16 tan to the power minus 1 x upon 1 plus x squared dx. So we just integrate this. Just integrate this to the tan x and 1 plus x, which is the denominator, with respect to x0. If we run this, we will get the value of 2 pi squared. Next, we have dot products, which is simply the for dot products we are simply using numpy. So this is a array, this is the another array, and numpy has inbuilt, which is called np.cross. Oops, I think we have to use dot here. Well, so if I use dot, you can see 32. If I use cross here, it will use 32. So yeah, that's all about from my side, and I hope you enjoyed the presentation. If you have any questions, just let me know. Thank you.
Thank you very much, Gurav. I think the talk was really interesting. And of course, the fact that you mentioned that you were in high school is even more impressive. Just a quick question. I mean, you mentioned this, and I would like to know, like, does anyone else from your classmates also are using this to somehow help the way into getting math done? Or is it something that you believe that you are one of the only ones?
In my school, I think I am the only one, but I have a couple of friends that they are using this.
And do you have any restriction at school that maybe I don't know some professor tell
No,
you
this is
like
like
don't
we
use it?
are doing for like fun things, like learning more about the Python and more about the Python libraries.
Okay. Okay, that's really really nice. I mean, if you are doing this thing at the moment, I am pretty sure that you will be even crazier stuff in a couple of years, something. So keep up the good work, and it was really really nice talk to, and really nice to have you around.
Yeah, thank you.
Okay, see you next time. Okay, folks. So we are almost there. We have the last talk with a really, really cool topic as well. We will be right in a couple of back in a couple of minutes. So stay tuned. Hello, hello. So we have finally now the last talk of the conference. The topic is a really interesting one as well. I mean, as you might have heard about design patterns, usually they are like, these language agnostic thing solutions that people recommend to do in different situations. Maybe if you're doing graphical applications or website, the MVC pattern, or maybe, I don't know, if you are doing other things, you have like adapter, factory, singleton patterns. But now, we have now Azure that will talk about a really interesting one, which is the composite pattern. I would like to invite now Asher to the stage. Hey, Asher, how are you?
Fine. How are you? Good to see you.
Good, good. What time is it? Where are you joining
It's
from?
9:30 in Tel Aviv. Nothing. 9:30 in the morning. So it's
Perfect, perfect. So only 1 hour ahead
perfect time for presenting, right?
Exactly. Cool. So I can see your screen here. Now it's on the stream, and I will not take more of your time. And good luck with the presentation.
Thank you. So let's start. Hi everybody. I'm going to talk about particular implementation of composite design pattern in Python, providing some rationale why did we do it and how we did it. Couple of words about myself. Normally some with joke that people do not live so long in our industry. Well, I'm an exception maybe, but I really like what I'm doing. My areas of interest are cloud architecture, domain-driven design, promise theory, and complex adaptive systems. Here are some links where you could find more information about I will post this presentation on SlideShare right after the conference. So topics to cover today. I really want to spend most of the time on implementation. So I will pass through preliminary stuff quite quickly, but if you have questions, just stop me and ask them. So brief introduction into design patterns topic. More definitions, formal definition is existing on Wikipedia. The story started in the previous century by a seminal book called The Timeless Way of Building. If you like some kind of techno-philosophy poetry, it's a good reading, really, and the original idea of design patterns came from here. It was generalized by community, and in mid-90s, was a seminal book of design patterns published by these four guys. It's a book called Gang of Four. It's still fundamental in this area, but examples are a bit outdated. They are mostly in C++ and Java. There's a good GitHub repository and examples of implementing design patterns in Python. So we recommend it. Let's move. So composite design pattern. When we need it, it's a good candidate whenever we have any form of nested recursive or tree-like structure, be it file system or code structure or any hierarchical data structure is a good candidate for that. The official implementation looks like as follows. We have a normally abstract base class or interface with one or more operations, normally abstract. We have one or more implementations of that abstract interface. And then if we want to treat a collection of these different implementations as yet another one, actually implementing the hierarchical structure, then we derive a composite from this base interface and define the same operation, which is some form of iteration of a child. And here the object structure of that implementation. It has some limitations. I need to overload overload depends on which language you're coming from. All methods in abstract interface. While implementation is mostly trivial, I need to go through childs and perform some, invoke corresponding methods and perform some aggregation. I could go depth first or breadth first, but very often people don't care which one. And that's okay if the number of methods or base class interface is stable. That was not my case. So I will give you a background where I started from. This activity, relatively new one, kind of considered continuation of infrastructure as code. Here's infrastructure from code. And the challenge is to pick up plain Python application code with some configuration also in Python, and to translate it into 4 different interactions with cloud services, like acquire resources, configure resources, consume resources, and operate them in terms of monitoring, alerting metrics on different clouds. And the point is that we have different services, some of them coming from different vendors, they have different levels of APIs, and could be located, deployed in different locations. So it's a pretty challenging structure. I recently published an article on Medium describing this mechanics. So at the heart of that translation activity, we treat cloud as a hardware, and we just built an operating system for it with compiler. So I had a resource template builder. One of the APIs to communicate with cloud services is so-called orchestration engine, for example, CloudFormation on Amazon or Terraform on Terraform. And I need to build 2 groups of elements, descriptors for here, right? One is the general service level, and another at the individual function level. Again, details are less important here, but I came up with the need to keep them as a composite. Why? Because every high-level feature, like I want MySQL database, but MySQL database is translated into multiple resource descriptors on CloudFormation, for example. And it might have different variants inside, sub-features. For example, do I have encryption? Or do I need to put my database in a virtual private cloud, which is called private network? In other cases, what form of user authentication I need, or which interface I want to interact with this service. I could interact with MySQL through DB connection, plain DB2 API, or SQL Alchemy, for example. And that led me to some kind of deep nested hierarchical structure that I need to build dynamically from configuration. And here we come to a very important topic, maybe one of the most important in this conversation, is called design pattern density. Design patterns seldom come in isolation. You seldom use only one design pattern. You put multiple design patterns together, and that is considered a certain metrics of design maturity. However, novices very often mess up themselves. If it's not done correctly, it's a disastrous over-engineering. In my case, I hope it was not. So we have a bunch of design patterns applied simultaneously. Right? First of all, this is a builder design pattern, right? Which builds out resulting template, be it CloudFormation on Amazon or Terraform or ARM on Azure or Deployment Manager on Google. But I also applied null object pattern, which actually says provide default implementation of these methods, returning nothing, because every individual resource per template builder will need to implement only some subset of these methods, and you don't want to replay them. Then we have composite design pattern and iterator together. I will justify it shortly, which puts them together in nested hierarchical structure, implemented in a form of class decorator. So it's a decorator design pattern. Building of this hierarchy of creation of this hierarchy of builders is done through factory method. which looks at specification. In addition, I created another decorator because the decorator. Not essential for that discussion, but it's just funny observation. Now let's look at the code. Composite design pattern, we just use Python decorators. At this wonderful conference, we had very interesting presentation about Python decorators. So basically say composite, make this class composite from that base class. That's it. So as a side observation, it actually behaves as a pass-through gate, because if I don't override these methods, it will call them. As a complementary part, as a decorator that blocks them unless I do otherwise. Interesting observation. It allows create a quite sophisticated logic of access control management and all this stuff. Now we go to how we implement it. It's an interesting Python meta programming exercise was for me. And I hope you will get some ideas, understanding that you could do a lot with Python meta programming if you need to. Python decorator is just a function that as a parameter gets a type class and returns type. So we just get input type and return other type. Now, what I need to do here, I could create type dynamically, this line, providing its name, base classes, which I steal from the original class, and a dictionary of attributes. Now, I build dictionary of attributes by calling an internal function make method. We will see it in the next slide. By traversing class members, which are functions. This comes from inspection library of Python. And I skip over private method. That's questionable decision, because by that I also filter out magic methods, but that's current implementation. In addition, I specify a constructor for that new class, and I make it an iterator. The whole code structure is a kind of top-down decomposition. I specify what I need at high level, and then I just go into details. Constructor is quite trivial. I just need to store all parts or childs as my internal attribute. That's not complicated, right? In make method is where real stuff is done. Let's recall the original idea. I need to take original method specification and convert it into iteration over child class objects, calling this method one by one. There's a difference. The difference is whether I'm dealing with void method, which returns nothing, or it returns something. How could I detect it? I could use introspect signature library, signature function, get the function signature, and look at return annotation. Now, Python with type annotations creates a certain challenge. It could be normal type, like integer or tuple, without any bracket parameterization, or could be something like that. For that reason, I need to strip down annotation parameters, and I could ask for origin if it's not none. If it's none, I take just original type. And then I could analyze if it's none, I need to create some form of for each iteration. And if it's not none, if it returns something, I actually, as we said, as we discussed, it's an aggregation of child objects invocation. So it's a reduced algorithm, right? So again, it's top-down decomposition in action. Pay attention that I just specify to high level what I want to do, and then I go one level deeper and deeper and deeper. make which is pretty boring. I just run for loop, extract. Let's not forget. I get a method name here, right? It's a method name, and I define inner function. In decorator presentation, it was discussed in more detail. There is a so-called Python closure gotcha. Very roughly speaking, parameters are passed by value in Python, but closures are captured by pointer. If I don't specify inner function for that, it will always point to the last method. So I define inner function that will retrieve from every object, and self is iterable. We'll see it shortly. Retrieve the method by name from that object and invoke it, passing args and keyword args. So this way I created a new function, new member function, right? Because it gets self for any original function of the base class that will go through parts, through child objects, and invoke them one by one without treating any return value, because there is no one. And it just creates a function on the fly, right? In Python metaprogramming, functions are first-class citizens. Make reduce is more interesting, because here the same problem of closure gotcha. I need to define internal function, but in addition, I need to do more things here, right? First, I need to get initial value for particular return type. Apparently, it's just calling this return type with parentheses. And second, I need to detect which combination method to use. And here is probably the most interesting part of the solution. If it's integer, string, or tuple, I could use add operator. I just could use plus. But if it's something else, like sets, lists, or dictionaries, there's a remarkable library called deep merge that performs deep merge of this data structure. So I could take one dictionary, another dictionary, and merge them together, not overwriting. This is pretty cool stuff. Okay. And then we just invoke reduce algorithm, right? Providing init value and combination, combining the outcome of calling that function. Iterator is interesting. It's most tricky. It's built on top of DQ, but I didn't write it. I just stolen it from Stack Overflow. It's a cool algorithm of deep first traverse, but I will not get into details here. If you want, could take it offline. And now we will look at another more, in a sense, advanced use case. I also need, because our compiler system compiles to Cloud Functions and Kubernetes from the same source, we need to build Kubernetes manifests. And guess what? Kubernetes manifests is also composite of different parts, each one with its own details. But the point here is that I need all of them. I don't have specification. At the moment, I just needed to collect all of them. And here's a nice trick we could apply. Again, playing with basic Python facilities. I could just traverse models on the same path I have, import them one by one. And since they all these subpath builders are in the same package, they will be collected by Python and subclasses magic method. And then I could create a composite for that. It was pretty cool because the original version of guys who developed it without using composite, they get a very long monolith function of generating Kubernetes manifests with a lot of conditional logic inside and a lot of duplication, and that just shrinks it down by an order of magnitude. Now, let's look at concluding remarks here. I did not implement visitor pattern. It could be done. It's not complex. I did not have any strong reason for doing that. But if somebody does, drop me a line. We will consider it. The current set of aggregation functions is still a bit limited. We had a presentation at that conference about functional programming in Python. So in functional programming, they very often use, especially in Haskell, use the concept of monoid. Monoid is a special set of data type and operation when you have initial value in some accumulation. So with the current implementation, I only use add or deep merge, but I cannot multiply. So the current implementation, for example, automatically will implement any function for Boolean return values because we just add them, but cannot implement all. So we do not implement monoids here. We do not parameterize. It would complicate the interface, so I didn't want exactly to do that. But I could easily imagine that some use cases might justify using additional parameterization of what kind of monoid you want for aggregating results. The current version, and it's a good side effect of presenting in conference because it forces you to clean up your code. The current official version deployed on PyPy is slightly different, and this one is on a separate branch. We will release it quite soon. A couple of things to remember, to recall from that, to take from that. To take from that presentation, design patterns are extremely powerful, really. I mean, if you take some time to study them, they could create a difference between make and break on with solving complex problems. Usually they come in concert with design pattern density. Seldom, it's like using one word instead of creating sentences and telling the story. You need more than one in one place. Composite, very powerful when you have on-off feature logic, kind of hierarchical structure of features. And variable lists of components, you just don't want to bother to put them manually. Python metaprogramming is miracle. I mean, you could do much more probably than people think. Again, if you took the right angle to look at them, but with more power comes more responsibility, and if people start just chasing after advanced technologies, it's a sure to hell. You need to understand what you are doing. But if you do understand, it's extremely powerful. It really makes the difference. That's it for now. Any questions, I will be really happy to take. Otherwise, I will upload this slide deck to SlideShare shortly, and you can reach me out. Thank you.
Thank you very much, Asher. Yeah, I mean, that will be really great. There were many references and resources during your presentation, so it would be really cool if you could share it around and maybe on Discord.
Sure. I will upload it immediately.
Perfect.
And thanks for giving me opportunity. It's a cool conference. You don't need to travel, don't need to suffer from jet lag.
And you can be in your pajamas as well.
And you could be in your pajamas. Exactly.
Thank you very much then.
Thank you. I will stop sharing.
Okay. Bye-bye. Thank you. Okay, now, and we will have now the closing session in a few minutes. Not sure if that will be, maybe we can start that before, but I will put the video once more.
Okay, forgot to put myself on stage. Hello. It is time to say goodbye. You can see I have my teddy bear in my pillow, so I'm ready to go to bed finally. But not yet because we still have the closing session. So let me put the banner away first of all. This one. Oh, sorry, someone did already. Okay, cool. Yeah, there's more and more mistakes now since I'm getting more and more tired. Let's see how am I gonna do this. I'm gonna share the screen here. Hello, everybody. So yeah, this is the closing session. So just gonna quickly wrap up what has happened. So first of all, code of conduct. We have no reported cases. We do have some. So everybody was actually nice, including questions for speaker. We have very good interactions on the stream, except there's a few spam that's definitely not from our content, our conference attendance. There's basically some spam bot, which we have reported and blocked them already, so that's fine. And also, thank you for the speakers. You can see the beautiful faces on, our website. So if you want to also check, what talk has been given and stuff, you can check that as well. So, yeah, just so you know. And so what happened is that we have two non-English talks. We have one Italian talk and one Spanish talk, which is super fun. We could do better, hopefully, in the future that maybe we have more non-English talks to kind of adapt it to a variety of audiences. We also have two Pyjamas retro talk, which is a few of the our favorite talks in the past from the past edition of Pyjamas. We also have one talk that the speaker, there's some technical difficulties, so but the speaker was very nice to record it so we can reschedule it and play it later. So also, ta-da! Someone win a book. So I have collected lots of people joining the raffle. And after just using a very simple, deadly simple code, not Python code, I'm just writing it, random on a spreadsheet, and then we have draw a winner that is Sean. So yeah, you know who you are, and then we would actually contact you maybe in a day or two to get the code to redeem the book. So next, merch shop will still be open. We won't shut it because we're not making profit. So it's just for your funsies. If you have seen some of our volunteers or speaker wearing very cool merch, you can also get it for yourself. It's online, so check that out. So actually, we do have speakers that really make an effort. That is amazing. Our developer Steve, one of our speaker, has a really great costume. And fun fact, he's actually based in Australia, and then he's wearing this onesies. At the temperature, there's 30 degrees Celsius, something like that, and having a dinosaur as the background, which is amazing. So yeah, definitely check that out. If you missed the talk, check that out. It's a really good talk. So thank you very much for all the volunteers. So these are a few of them, organizers and also people who help hosting the session. So they're the beautiful faces, and also CFP reviewers. Danny also helped us to host sessions. So if you want to see them, go and play back the videos, the live streams. They will be still be accessible on YouTube. So also thank you very much for the donation. So far we have made around, so it's not very accurate accounting at the moment. It's just we just have a brief look at how much we made from the tickets. So this is the amount that we made, $278.11 US dollars. So but it's not the end of it. We would do a proper accounting, kind of check all the donation, check how much we made this year, and then we would calculate. Of course we have some small amount of money that we spend to run this conference. There's some technology that we use, we have to pay for them, but later, sometime in the future, we would be having a proper accounting announcement and how much money we are donating, and all of them will be public and announced. So, last thing, need to thank you for all of you who have participated in this conference. Again, like it's very fun. If it's not without, like, if it's without you, then it won't be so much fun. And so thank you so much. And until next time, we'll see you again. I don't know when. So just pay attention to announcements. So we will see it. And so I think that's all for the presentation. And maybe now we'll invite all the volunteers who are here now on the live stream to be on stage and maybe say a few words and say goodbye to everybody. So do you want to come on stage? Just put yourself on stage when you are you falling asleep?
Hello. Yes.
Hello.
I'm sleeping.
Oh, okay. Cool. So yeah, how's everybody? Are we ready to go to sleep, or have you sleep, or you awake like me? So yeah.
Oh, Martin is muted. Martin, I think we cannot hear you. Well, you're not muted on the platform, but we cannot hear you. In the meantime, yeah, we cannot hear you. Oh, well, in the meantime, yeah, I did manage to sleep some hours. But I woke up like 2 times in the night, like thinking, oh my God, I need to wake up because it was, I had an early session this morning. So yeah, but I managed to sleep a couple of hours.
Yeah, so I have actually managed to have a nap in the break time. So that's my
Hey, nice.
Yeah, that's my break. But my key to stay awake is to have food. So I have lots of food still like laying around my computer. So when I feel like tired, I just have more sugar, have more sweet stuff, and yeah, that's how I survive.
What about now, Martin? Can we hear you?
So I hope it works now.
Yay!
Actually, the cable of the USB microphone went out. So these are the things.
Okay.
Another technical difficulty at the end, so that's perfect.
Yeah, thank you very much for the opportunity, by the way. I mean, it's the first time that I managed to participate in the conference, luckily as a speaker and also as a host. So thank you very much.
Yeah, you did a lot of great work. So thanks, especially for doing the night shift, because that is the one that is the most stressful one. And I really like your glasses.
It's just to hide my terrible eyes now, since I woke up a couple of hours before.
I think we all need one. Maybe we should sell it in the merch shop or something.
Yes, for sure.
Sunglasses for not enough sleep eyes. So yeah, I think that's the end of it, and I really need to go to bed right now. And hopefully I will be wake up in time for lunch. So yeah.
Yeah. Thanks for staying awake the whole night.
Exactly, and it was fun to be with all of you. And well, next year, if you see any of us in one of the conferences, just come up and say hi.
Exactly.
Okay, so I'm going to go to bed as well. Goodbye.
Yes, me too. Bye-bye. Thanks for everything.
Bye.